Consider the system of linear equations. There are three equations and three unknowns x, y, z, right? Three variables. If this system of linear equation has infinitely many solutions, then we have to comment about another system of linear equation in K, right? Variables are x and y, and we have this system of linear equation, two equations, two unknowns, right? And we have to comment about this system of linear equation, that whether it will have unique solution or no solution or infinite number of solution, right? And also for unique solution, there are two different cases. Now, we know that for infinitely many solutions, right? If we have a system of linear equation, three equations, three unknowns, then for infinitely many solutions, the condition is that determinant of coefficient matrix, this is 0, and then delta 1, delta 2, and delta 3, these three are also 0, right? This is the condition for infinitely many solution. Now, because there is only one unknown in this equation, k, so using this condition, delta equals to 0, we can get the value of that k, right? And once we have the value of k, then we can comment about this system of linear equation, that whether it will have which one of these options, unique solution, no solution, or infinitely many solutions. So first of all, let us equate the determinant of coefficient matrix to 0 and then see what is the value of k that we are getting, right? So because it has infinitely many solutions, the determinant of coefficient matrix must be 0. That is necessary condition but not sufficient condition. Sufficient condition will be that delta is 0 and these three are also 0. But because we have to find the value of this unknown k only, there is only one unknown. So by equating delta to 0, we can get the value of that k. So for delta, the first row will be 1, 1, and then k. Second row will be 2, 3, and minus 1. These are nothing but coefficient of x, y, and z. First row means coefficient of x, y, z in first equation. Similarly, second and third equation. So third row, this will be 3, 4, and 2. So this is the determinant of coefficient matrix. And because the system of linear equation has infinitely many solutions, this must be 0, right? So if I expand along, first row will get 1 into, and then 3 into 2, 6 plus 4. So that will be 10 minus 1 into, and then 4 plus 3, that will be 7. And then plus k into 8 minus 9, that is minus 1, and this must be 0. So from here we'll get k equals to 10 minus 7, that is 3. So this is the value of k that we are getting, right? If the system of linear equation has infinitely many solutions, then k must be 3. And now let us substitute that value here in this equation and try to see what type of equation we are getting. So if k is 3, the first equation will be 4x plus 5y, and this equals to 7. Second equation will be, in place of k, if I write 3, then we have 7x plus, here we'll get 3 plus 5, so that is 8y, and on right hand side we'll get 10. Right, so this is the system of linear equation. Now for two equations, two unknown, we know the condition. I mean, if we have this system of linear equation, a1x plus b1y plus c1 equals to 0, and another system of linear equation, a2x plus b2y plus c2 0. So these are nothing but equation of a straight line in 2D, right? Linear equation in x and y, that will represent a straight line in 2D. And if a1 by a2, this is not equal to b1 by b2, then it means the lines are not parallel, and in that case we'll get unique solution. Also, for infinitely many solution, a1 by a2 is equal to b1 by b2, it's same as c1 by c2. And for no solution, these two are equal, a1 by a2 same as b1 by b2, but not equal to c1 by c2. That means in that case the lines are parallel. So here if you notice, we are getting this first case, right? a1 by a2, 4 by 7, this is not same as 5 by 8, or clearly for these two lines their slopes are different. So that means we'll get a point of intersection between these two lines, and therefore we'll have unique solution. So no solution and infinitely many solution, these two options are incorrect. Now we have to check whether we are getting solution satisfying this condition, x minus y equals to 1 or x plus y equals to 1. So for that, either you can solve these two and then find sum or difference of those two roots. But here directly also you can see that if I do 2 minus 1, right? If I let us call this equation as 1 and this equation as 2. So if you do equation 2 minus 1, then you will get 7 minus 4, which is 3x, and 8 minus 5, which is 3y, and right hand side 10 minus 7, that is 3. Divide by 3, and then we have this option x plus y equals to 1. So therefore, this system of linear equation will have unique solution satisfying this condition x plus y equals to 1. That means sum of those two, when the sum of solution, that x plus y, that will be 1, right? So this was a problem where first we had to find the value of k using the condition that this system of linear equation has infinitely many solutions. So for that, condition is delta 0, and then delta 1, delta 2, and delta 3, those three are also 0 because there was only one unknown k. So by equating delta to 0, we got k as 3. Once we have k as 3, we got these two equations. And because a1 by a2 is not same as b1 by b2, the lines are not parallel, we'll get unique solution. And if we do 2 minus 1, then the solution will satisfy this condition, x plus y will be 1. So therefore, the correct answer for this problem is option C.